Cybersecurity protects assets and economic activities through the protection of information. Confidentiality, prevent the disclosure of information to unauthorized individuals or systems. Integrity, data cannot be modified without authorization. Availability, information must be available when needed. Delaying information availability can also cause loss to the revenues. It ensures organization procedures and security rules, people personnel information security. Products and assets security. The supplier's responsibilities includes: design products and solutions with security features. Ensure they enable customers to comply with security standards. Provide recommendations and methodologies to guide implementation. The user's responsibilities includes: define security procedures, organizational security. Mandate responsible people, personnel security. Ensure compliance with security standards. Here are some false myths of cybersecurity. My industrial automation and control system is protected because it is not connected to my enterprise network, uses proprietary industrial networks, seldom or even no remote access, proprietary application tools for operation and maintenance. Here are justifications. IACs nowadays mostly use commercial operating systems and open networks, while supporting remote access. Hackers are being hired like any other professionals and they know our industrial technologies at least as well as we do. Disgruntled or careless employees or outside contractors can cause system outages from within the enterprise. I should rather not make noise about security in my organization because it could provide useful technical information to potential hackers or ill-intentioned persons. Here are justifications. Most incidents are the result of human errors and not deliberate actions. Not putting in place an internal organization to manage those risks will increase their likelihood. If events occur, the company could face irreparable damage to its reputation. Recommended solution is to defense in-depth approach. Here are 6 key steps. Let us elaborate each. Security plan, create, apply and update security policies and procedures. They must assess vulnerabilities, mitigate risks and define how to recover from outages. Network separation. Fully separate the industrial automation and control system from other internal and external networks by creating demilitarized zones. Perimeter protection. Protect the industrial automation and control system from unauthorized access by using firewalls, authentication, authorizations, VPN, LSEC, and antivirus software. Also take into account the remote access to the IACs. Network segmentation. Make use of switches and VLANs which divide the network into segments. They enable the containment of a potential security breach to only one segment. Device hardening. Configure packs, PCs, switches, LO and instruments for increased security, strong password management, user profile definition, deactivation of unused services and interfaces. Monitoring and update, permanent surveillance of network communications and all operator activities. Software and firmware updates to reduce vulnerabilities. Now let us look at a very lethal attack in cybersecurity, that is of attack. Denial of service and distributed denial of service attacks constitute one of the single greatest threats facing business today. It is costing in billions of dollars in lost reviews and market capitalization, not to mention cost of damaged reputations. DOS also sees significant liability risks for service providers. DOS refers to the disruptions of service that occur when hackers or intruders make computer systems inaccessible by overloading servers or network devices so that legitimate users can no longer access those resources. Here situation of normal network situation is being displayed. In an ideal situation, users access their favorite websites instantly. All of the component of the network infrastructure, the hosting service provider, servers, routers, and load balancers, contribute to the user performance experience. The system is surprisingly resilient in the face of everyday traffic and congestion. However, it's deeply vulnerable to attack. Next here is normal attack scenario. Hacker breaks into many machines across the internet and installs stealth process called daemons lying in wait to attack. At a signal from the attacker, these zombie machines, which might be unsuspecting end users or even other websites, begin flooding the victim websites with more traffic than it can handle. Now let's see attack situation. On attack, ordinary users are elbowed out and are denied access to their favorite websites as the victim websites copes with the flood of meaningless traffic. Some of the infrastructure behind the website, such as servers and routers, can crash, load balancers can fail. Thin pipes are overwhelmed, but the net result is users cannot get through, and sometimes it lasts for hours. Meanwhile, the victim website may lose millions in revenues and productivity costs while their employees scramble to fix the problem. Next is how DOS disables the network. Attacks take one of the following forms. Those that consume server or specific application resources. Those that consume network bandwidth and router resources. Some of the DOS attacks target servers specifically, overloading, for example, their processors or network connection. Others target the network as a whole, consuming network bandwidth and router resources. These attacks were the type that brought down prominent e-commerce and portal websites in February 2000. Servers, routes, load balancers, firewall, all are at risk from these broader attacks. There are specific types of attacks. Flood attacks are the most common kind of DOS attack, and currently the most difficult to prevent. In a flood, the attacker overwhelms the targeted server, or other infrastructure between the attackers and the target, such as a router, by sending the target a huge number of packets. Attacks may come from one machine, or from many machines working in concert. In the latter case, the attack is a distributed denial-of-service assault. The individual attacker machines need not send very much traffic to overwhelm the victim. Worse, the internet allows attackers to fake packet source addresses. Thus, the server cannot find where the attack is coming from without help. UDP is just one kind of protocol that can be used to launch flood attacks. Almost any other kind of traffic, including web traffic, can be used to implement a flood DOS attack. Now let us have a look at SymFlood attack. The SymFlood is one example of a common attack on servers. The attacker machines send out thousands of TCP SYM packets, the kinds of packets that normally introduce meaningful communications with users. The server must wait for replies. But none are forthcoming. Think of a crank phone caller calling millions of times and hanging up. Just a couple thousand packets and incapacitate a server for minutes at a time. Newer load balancers can protect websites against SymFlood attacks, but are powerless against sophisticated network attacks. Now the Smurf and Fraggle attack. The Smurf and Fraggle attacks use faked source addresses and broadcast addresses to amplify an attack, tricking many machines into flooding the victim with traffic. Most servers on the internet accept and generate ping packets, small messages that let an administrator know that a machine is still live. In the Smurf and Fraggle attacks, the attacker generates a ping request that looks like it came from the targeted server. This request is then sent to an IP broadcast address. This means that every machine on a given LAN will receive the request. Now the attack scenario. The Smurf and Fraggle attacks use faked source addresses and broadcast addresses to amplify an attack, tricking many machines into flooding the victim with traffic. Most servers on the internet accept and generate ping packets, small messages that let an administrator know that a machine is still alive. Now let us go through Smurf and Fraggle attack. In the Smurf and Fraggle attacks, the attacker generates a ping request that looks like it came from the targeted server. This request is then sent to an IP broadcast address. This means that every machine on a given LAN will receive the request. Now, the fragment attack scenario: internet IP packets can be up to 65,535 bytes long. Most links, however, have a much smaller maximum packet size, such as 1,500 bytes. Large packets must be fragmented into smaller pieces before they are sent over these links. The pieces are labeled so that they can be reconstructed into a single large packet at the receiver. However, attackers can generate these labels themselves, choosing malicious labels that confuse some servers. Let us see the fragment attack scenario. The server's CPU and memory resources can quickly run out as they try in vain to reconstruct full packets from these malicious fragments. On some systems, Windows 95 and NT4 are particularly notorious for this vulnerability. The attack makes the entire system crash. Fragmented attacks are not just a server problem. However, firewalls and intrusion detection devices are also frequent victims. That is all from DOS attack and its different variants. Thank you for watching.